Hello. This is your algebra lesson for Friday, March 5th. This is Mrs. Craven talking, and I am posting this video for both my classes and Mrs. Toth's classes. We're going to cover fractional exponents and how they work. You had a little introduction to them on your math notes, and now we're going to walk through the process of how they connect to radicals and roots, which you've been using to find multipliers with exponential relationships. It would only make sense that since we're in the exponential world and we're dealing with using roots to undo multiplication, that square roots and exponents, radicals and exponents are inverse relationships. So cube rooting something and cubing it, those would undo each other. Square rooting and squaring undo each other, just like adding and subtracting the same number, just like multiplying and dividing by the same number. So we're going to go through this process. Addison has worked through this process of trying to come up with a way to write the cube root of 17 with exponents. And she starts simply by writing this equation, that 17 to the x power is equivalent to the cube root of 17. And now she's going to try and figure out what that value of x is. If you have any guesses, if you think you might know, I would encourage you just to jot them down. Hopefully you have this document. You should have this document open in front of you or have your notebook in front of you so you can follow along and make some notes. You will be having some problems that you have to complete on your own at the end once you have finished the video, as part of your assignment that will be due on Monday. All right, so Addison says, well, we know that the cube root of 17 cubed is 17. I said that earlier in this video. And since she wants to write the cube root of 17 with an exponent, then she's just going to take this idea of, I'm going to change colors here for a second, of replacing. Because we've stated this equality up here, she's going to substitute in for the cube root of 17, 17 to the x power, and state that, well, since 17 to the x is equivalent to the cube root of 17, it must equal 17 when I cube it. So that seems logical. That seems like a logical first step. She recognized in looking at that when you have a situation where you take a base and you raise it, a base that's raised to an exponent, and then you raise it to another exponent, this is one of our power properties. It's the power of a power property. And we know that that's equivalent to k to the mn. We multiply the exponents in that situation. So we're going to use this property. We're going to apply it here and say, well, if we have 17 to the x power being cubed, that's equivalent to 17 to the 3x power. And so now she's at this point where she's saying, well, that means that that's equivalent to 17 to the first power. And I think there's a lot going on here, so I'm going to start at the beginning, and I'm going to write this out again for you, talking through the steps and get us to the point where we're at in this part D. So again, Addison started out saying 17 to the x power would be equivalent to the cube root of 17, so that she can solve for x and figure out what that exponent must be that would make it equivalent to the cube root. She is undoing the cube root here by cubing it, and since it is an equation, whatever we do to one side, we have to do to the other. This causes the right-hand side to be 17. It causes the left-hand side, applying this property, to become 17 to the 3x power. Now 17 standalone by itself is equivalent to 17 to the first power. And since we now have bases that are identical, so we have 17 to the 3x power and 17 to the first power, and we're saying that those two must be equivalent to each other, then it means that the exponents also must be equivalent to each other. And then this is a simple one-step solve. So we get x to the 1/3 power. Therefore, which is also sometimes written as 3 dots like this, that symbol right there means therefore, we can state that the cube root of 17 is equivalent to 17 to the 1/3 power. All right. We're going to walk through that process. I'm going to walk you through the process one more time with the square root of 5, and then I'm going to ask you guys to stop the video and walk through that process by yourself for the 5th root of 11. But we're going to start with the square root of 5. I'm going to start it again. So we're looking for an exponent that represents the square root of 5. You guys probably can already guess it. Anytime a radical sign does not have a number written outside up in this corner, it is defaulting to a 2. So we're going to square this square root here. When we square the left-hand side, we have to square the right-hand side as well. On the left, that gives us 5. On the right, it gives us 5 to the 2x power. 5 by itself is the same as 5 to the 1st power. Again, we have bases that are identical, and therefore the exponents also need to be identical for them to be equal. Dividing both sides by 2, we get x must be 1/2. Therefore, if you remember, that symbol means therefore, the square root of 5 is equivalent to 5 to the 1/2 power. All right, and again, I'm going to ask that you guys follow that same process. Complete the process for the 5th root of 11. And we'll be looking to see that on Monday when we go over this. All right, moving on. So in this next little section, they're highlighting again this idea of the power of a power property, and we're going to use that to go back and forth between fractional exponents and radical forms of a number. So we're starting with this idea of 16 to the 3/2 power, 16 to the 3/2 power. And they're saying, hey, look, you can take that and you can break that fraction apart and make it a product. So essentially, we're going in reverse of this power. We're starting with it already together, and then we're breaking it apart. So we're going to rewrite it as 16. Actually, I'm going to write that just a little differently. We're going to write it over here as 16 to the 3 times 1/2 power. And then I'm going to put my parentheses in to match what's going on up in the power property that I highlighted just above. So looking at this, I could rewrite this. I could say, hey, since I could write that as a product, now I can take that 1/2. I know 1/2 means the square root, so I could rewrite this as the square root of 16 to the 3rd power. I could rewrite it as the square root of 16 to the 3rd power. But we know that the commutative property exists, and that means that we can take a product and we don't have to write it as 3 times 1/2. We could also write it as 1/2 times 3 and put our parentheses around this a little bit differently. And if that's the case, then I'm looking at the square root of 16, having that 1/2 right up against the 16 there inside the parentheses, and cube it. And the nice thing about that is that we know what the square root of 16 is. It's 4, and this becomes 4 to the 3rd power. So what you're seeing here is this is the first way that they write out the exponent of 3/2. And then they say, but we could also write it this way, which gives us this radical form and even more simplified in an exponential form with an integer exponent instead of a fractional exponent. And that's what's happening over here on the right-hand side. So a couple of different ways. It's just manipulating the numbers and writing them in different ways. Sometimes that works for us, sometimes it doesn't, but that's what we're going to be practicing. So there are 6 problems asking you to rewrite each one of them in 2 different ways. And I'm going to take you through the first one, the 10 to the 2/3, and show you, actually, I take that back. The 10 to the 2/3, the 5 to the 7/2, the f to the 3/3, all of those would follow just like the example above. Just like the example above. So this one here, I'll put a star next to this example. Well, let's make that a different color. So let's highlight that in orange. So this right here goes along with this problem, and this problem. And then I'm going to walk you through part B because that's a little different. So B is already in radical form and they want you to write it different ways. So we're going to take B and we're going to transfer it into different forms. So I could go this way. I could rewrite the cube root of 9 as 9 to the 1/3 power. And then I know I'm raising it to the 4th power. And that then, multiplying those two numbers together, I'm going to multiply 1/3 and 4, would become 9 to the 4/3 power. That's absolutely one way that you could write this number. But now I have to think about that. What this also means is that I could change this, since I have it as 9 to the 4/3 power. I could, and I'm going to actually arrow over here, I could make this 9 to the 4th power to the 1/3 power. And that, notice all I did here is I reversed the order from what I wrote right here. So I reversed the order from what I wrote right here. So that's equivalent to, just so that I don't run out of room here, that's equivalent to 9 to the 4th is a big number, but I'm going to go ahead and write that out. I could write it as the cube root of 9 to the 4th, or I could write that as the cube root of 6,561. All of those are equivalent. I've given you more than 2 ways to write those. So I just wanted to give you examples. By manipulating those, you just have to make sure that they're all equivalent. You just have to make sure that what you're doing isn't changing the value of them. And you could test that. We could sit here and we could type it all into a calculator and make sure that our decimal approximations are all equivalent if you're worried that maybe it's not right. So your homework, the rest of your homework, is that you are going to, and I'm gonna highlight, I think in green, B, C, and D, because those will all work the same way. So the rest of your homework will be simply to finish the rest of the problems in this worksheet. So you've got the 5th root of 11 that you need to walk through that process there. And then you've got parts A, C, D, E, and F, in which you go through and you manipulate the values and rewrite them in at least 2 different ways, if not more. All right, so that's it. Hopefully you understood all of this. And we will see you guys back in the building on Monday.